Why can't we drink ocean water? Yet, imagine you're stranded on a lifeboat in the middle of the Pacific Ocean. Water stretches as far as the eye can see. You're surrounded by nearly 1.4 billion cubic kilometers of it. Yet within a few days, you'd likely die of thirst. How is that possible? How can a planet that's over 70% covered in water leave billions of people worrying about clean drinking water? And with all our modern technology, artificial intelligence, reusable rockets, and nuclear power, why can't we simply turn the ocean into an unlimited source of drinking water? The answer isn't that we can't. It's that nature has made it incredibly difficult and incredibly expensive. Chapter 1. The ocean is a giant salt soup. At first glance, seawater looks crystal clear, but every liter contains about 35 grams of dissolved salt. That's roughly 7 teaspoons. Imagine pouring 7 teaspoons of table salt into a 1-liter bottle of water. Would you drink it? Probably not. Most of that salt is sodium chloride, the same salt sitting on your dinner table. But seawater also contains magnesium, calcium, potassium, sulfate, and dozens of other dissolved minerals. These salts didn't appear overnight. For hundreds of millions of years, rain slowly dissolved minerals from rocks. Rivers carried them into the oceans. When ocean water evaporated, the water left, but the salt stayed behind. Over geological time, the oceans became an enormous reservoir of dissolved minerals. Chapter 2. Why drinking seawater makes you more thirsty. Here's the part many people find surprising. Drinking seawater doesn't just fail to hydrate you, it actually makes dehydration worse. To understand why, we need to look at your kidneys. Your kidneys constantly filter your blood, removing excess salt while conserving as much water as possible. But there's a limit. Human kidneys can only produce urine that's less salty than seawater. If you drink 1 liter of seawater, your body needs more than 1 liter of fresh water to flush out all that extra salt. That means you lose more water than you gain. Instead of hydrating yourself, you're slowly dehydrating yourself. This is why sailors lost at sea were historically warned never to drink seawater, no matter how desperate they became. The thirst becomes unbearable. Hallucinations can begin. Eventually, severe dehydration damages organs and becomes life-threatening. Ironically, being surrounded by water can be one of the deadliest places to die of thirst. Chapter 3. So why can't we just remove the salt? Actually, we can. The process is called desalination. Today, hundreds of desalination plants around the world convert seawater into drinking water every single day. So why isn't every coastal city using them? Because separating salt from water takes a tremendous amount of energy. Think of salt dissolved in water like millions of tiny particles, evenly mixed throughout every drop. Removing them isn't like filtering dirt with a coffee filter. The salt has dissolved at the molecular level. You have to separate water molecules from dissolved ions. That's much harder. There are 2 main ways to do it. The first is distillation. Heat seawater until it evaporates. Leave the salt behind, then cool the steam back into fresh water. It's simple, but heating enormous amounts of water consumes huge amounts of energy. The second and more common method today is reverse osmosis. This uses extremely high pressure to force seawater through microscopic membranes. Water molecules squeeze through, salt stays behind. Modern reverse osmosis is far more energy efficient than traditional distillation, but it still requires expensive equipment, powerful pumps, and constant maintenance. Chapter 4. Why isn't desalinated water everywhere? If the technology already exists, why do billions of people still face water shortages? The biggest reason is cost. Building a desalination plant can cost hundreds of millions or even billions of dollars. Running one requires a constant supply of electricity. Then there's maintenance. The membranes gradually clog with algae, bacteria, and minerals. They need frequent cleaning and replacement. There's another challenge many people never think about. What happens to all the leftover salt? For every gallon of fresh water produced, desalination creates an extremely salty waste called brine. If this concentrated brine is dumped carelessly back into the ocean, it can harm marine ecosystems by increasing local salinity and reducing oxygen levels. Engineers are working on better ways to manage or reuse brine, but it's still one of desalination's biggest environmental challenges. Chapter 5. Countries that already depend on desalination. Despite these challenges, desalination has become essential in some parts of the world. Countries in the Middle East, especially Saudi Arabia and the United Arab Emirates, produce enormous amounts of drinking water from the sea. Israel is another remarkable example. Today, much of its household drinking water comes from advanced reverse osmosis plants. Australia, Singapore, and parts of California also use desalination to strengthen water security during droughts. In these regions, desalination isn't replacing rivers or reservoirs. It's adding another reliable source when fresh water becomes scarce. As climate change makes droughts more frequent in many parts of the world, desalination is becoming increasingly important. Could future technology let us drink seawater without giant plants? Scientists are exploring exciting possibilities. Researchers are developing membranes made from advanced materials that could remove salt using much less energy. Some are experimenting with solar-powered desalination systems that operate without electricity grids. Others are investigating portable devices capable of producing drinking water in disaster zones or on lifeboats. There are even experimental methods using nanotechnology and advanced filtration materials that may dramatically reduce costs in the future. But no matter how advanced technology becomes, the laws of chemistry don't change. Salt naturally dissolves into water. Separating them will always require energy. The goal isn't to eliminate that energy cost. It's to make the process cheaper, cleaner, and more efficient. Conclusion. So, why can't we drink ocean water? Because our bodies simply aren't designed to handle that much salt. Our kidneys can't remove it without losing even more water than we drink. Technology has solved the problem through desalination, but at a significant financial, environmental, and energy cost. The oceans contain enough water to supply humanity many times over. The real challenge isn't finding water, it's separating it from the salt efficiently. Perhaps the next great breakthrough in human history won't be discovering more water. It will be making the water we already have accessible to everyone. If you enjoyed this video, don't forget to like, subscribe, and tell us in the comments. If desalination became almost free tomorrow, how do you think it would change the world?